This video is on the addition law of probability. Suppose we've got two events A and B in the sample space U. We should already know, hopefully, that the event that both A and B occur is called the A intersection B, and we use that notation there with kind of the N between the A and B. And then the event that either A or B or both occur is A union B, and we use kind of a U symbol between the A and B to represent that. Now, if we look at this little Venn diagram here, from this we know that the number in A is A plus B, because A is a whole circle of A, so it would be these two values added together, the A and B. Then the number in B is B plus C, so the B and the C, because they're the two values that are in the circle of B. The number of A and B is the intersection, so just the B in the middle. And A or B is everything in the circle, so A plus B plus C. With that, we can then put together this rule that is where the number in A or B is equal to the number in A plus the number in B minus the intersection. Now, the reason for this is we know A or B is A plus B plus C. Now, the number in A is A plus B. The number in B is B plus C. If you look here, we have an extra B to what we have on the left-hand side, which is why we need to minus one intersection to get rid of that one extra B. Then from this, we can make it into a probability because it would just be these values out of the total amount, the universal set. And this brings us to the addition law of probability, which is a probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Just a reminder as well, if events are mutually exclusive, then they have no common outcome. So the intersection is the null set, it doesn't exist. Therefore, in that situation, if they are mutually exclusive, the addition law is just where the probability of A or B equals the probability of A plus the probability of B. Note, this is for mutually exclusive only. A couple of examples. First one, two events A and B are such that the probability of A equals 0.4, probability of B equals 0.8, and the probability of A or B equals 0.85. Find the probability of A and B, and then the probability of not A and not B. So let's start with A first, and we want the probability of A and B. Now, if we look at all the information we've been given here, we can use our probability law, our addition law, which I'll just quickly write out here against the probability of A plus the probability of B minus the probability of A and B. Now, using this rule, we often do it, and we do often need to rearrange, which is what we have to do in this situation. So we already know the probability of A or B equals 0.85. That equals the probability of A, which is 0.4, plus the probability of B, 0.8, minus what we are trying to find, which is the probability of A and B. We can rearrange this. So it's the probability of A and B equals 0.4 plus 0.8, which is 1.2, minus 0.85, and we'll end up with 0.35. So the probability of A and B is 0.35. Now, part B, we want the probability of not A and not B. So if we think about a Venn diagram with this situation, the probability of not A and not B would be just the outside. Because it's an intersection, it's got to satisfy both not A and not B, so it's just the outside. So the probability of not A and not B is the complement of the union of the two. So it is everything that's not in the union, which means we can do the rule of 1 minus the probability of A or B, which will be 1 minus 0.85, which gives us an answer of 0.15. Example 2, a card is selected from a standard deck of 52 playing cards. Let A be the event the card is a diamond, and B the event the card is a jack. First one, find the number in A. So number in A, and A is the event the card is a diamond. So how many diamonds are in a pack of cards? That would be 13. Part 2, we want the number in B. B is the event the card is a jack. There are 4 jacks in a pack of cards. And the third part, the number in A and B. So we want how many jack of diamonds there are. So how many diamonds there are a jack, which is just one. Part B, now we want to basically create some probabilities. So the probability of A is, we know there's 13A, so it would be 13 out of the total pack, which is 52, which would simplify down to a quarter. Part 2, this time we want the probability of not A, so the complement of A, which is going to be 1 minus a quarter, which will equals 3 quarters. And then the last one, the probability of A and B. How many do we have in A and B? Just 1 out of the 52. Part C, find the probability of A or B. So probability of A or B, we have our rule. So the probability of A plus the probability of B minus the probability of A and B. Put all our values in. Probability of A is a quarter. Probability of B, now B was a jack, which word was 4, so that would be 4 out of 52, minus probability of A and B, which is 1 over 52. Now what we can do here to make the subtraction easier is let's change this a quarter to 13 out of 52. So we've all got the same denominator, and then we can just work that out from there. So it's 13 plus 4 minus 1, which is 16 out of 52. And if we want, we can then simplify that down to 4 out of 13. And then part D, we are wanting to find the probability that the card is a jack but not a diamond. So the probability of a jack, which is event B, or not a diamond. Once again, we can use the rules. If we do it in the order here, we've got the probability of B plus the probability of the complement of A minus the probability of B and not A. Now the probability of B, we know what that is. So there's 4 jacks in the pack of cards. So that would be 4 out of 52. Probability of not A is 3 quarters, which would be 39 out of 52. Minus the probability of B and not A. So if we already know there's only 1 jack of diamonds, it means we want to know how many other jacks are in the pack that are not diamonds, which is 3, so that would be 3 out of 52. And then we can just work this out and we'll get an answer of 40 out of 52, which is equal to 10 out of 13. And that's the addition law for probability.